Hey guys, morning all of you.
Good morning, bro.
Good morning, buddy.
Morning, sir. Morning, sir.
Good morning, buddy. Good morning. Hey guys, so yesterday we have done with the concept of a static route. Okay. Yesterday we have done with the concept of static route. Okay, and also we have seen what is the difference, right, between the word static and dynamic, right? We haven't discussed the dynamic routing because yes, but yesterday we have seen what is the difference between the static and dynamic word, right? And also yesterday we went through that what is the advantage of static route and what is the disadvantage of the static route. So hope this thing is clear to all of you, but still if you have any question from the static route, okay, you can ask me. Okay, if you have any question, you can ask me from the static route. Otherwise, we'll move to the dynamic one.
Yeah, I have got it out.
Yeah.
Um, so if primary in static route, if primary interface goes down, the traffic will be flown from secondary interface, right?
Yeah.
But what if another route means R2 router primary interface goes down?
Man, if you're going to if there is a one link right over there, there's another
Yes.
link. So this is a
Yep.
primary and this is the second. This is the router number one. Okay. And so router number two. So if this interface goes down, it means that this complete interface goes down, huh?
Yes. Yes.
Right?
Yep. See that's what I'm asking. If I'm pinging, if we do ping from R1, so if primary interface goes down, the traffic will be flown from secondary interface.
Right, right.
Uh, if the primary interface of R2 goes down, if I'm pinging from R1 means from which interface the traffic will be flown?
Of course, but it's secondary because what I'm telling you, if this interface goes down 0/0 on the R2 side, it means that the complete this interline protocol will down, right?
Yes, but what
Yeah.
the thing is, if when I'm doing practical, the ping is not happening. It's showing the
Of course,
destination host is unreachable,
it will go by this one secondary line.
but it did not. When that's what I'm asking.
It's not working.
Yes. It's not working.
Which one you did a practical on
Uh,
GNS3?
no, Telnet. Oh, no, sorry, Eve Engine. Eve
It
Engine.
should be work. Do on the GNS3. It should be work. If you're going to shut down this link, now the line protocol will down. This complete link will be down.
Okay, okay, sure.
Sir, hello.
Yep.
I have doubt in default route.
Okay.
In default route, we are configuring 0.0 with exit interface, right?
You can configure the next hop as well as.
Okay, so the that concept will be same for ARP. Means ARP concept.
Yeah, everything.
If I configure next hop IP, then one ARP with next hop it will generate for
Right.
all. And if I configure exit interface, then for each we will get one ARP, right?
Right.
Means the same ARP concept is same for default route also,
Right.
right?
Right. Right. Right.
Okay. Thank you. That's only.
So guys, in the dynamic routing protocols, right, we have a multiple types. We have a RIP protocol, we have a IGRP, we have a EIGRP, we have a OSPF, and we have a BGP, and we have a ISS protocol, right? According to your syllabus, only these things are present, right? EIGRP, OSPF, BGP. This is part of the CCI. Okay, not even the part of the CCI. This only comes if the person is interested to learn. I am teaching this thing. Otherwise, no. Actually, even the in a CCI lab exam perspective, if I'm talking about this is not there, right? This two parts is totally legacy. Totally legacy. It's the obsolete protocol. Nobody is using. But yeah, sometimes they will ask the question from the RIP protocol, right? Sometimes. So that's why in the group I have shared the one drive link of the RIP folder, right? Please watch the video. The basic things are there. Why? What is the RIP protocol? What are the timers of the RIP, and how the RIP is working over there. But today I'm going to discuss about these two types, right? What is RIP and IGRP, and why we are not going to prefer the RIP and IGRP in the market nowadays. So yesterday we have seen the concept of the dynamic, how the dynamic works, right? Let me show you the problem of the RIP. Let's do one thing. Let me start my devices. I'm again repeating. I'm not going to teach you the RIP right now. I'm just telling you the problem, right? So I already said the video on the Sunday. So hope you have watched that. If you didn't, then watch it. Okay, 1 minute. Let me check the things that I'm looking for. Two must be had. Okay. So guys, I'm gonna R1 and 1 minute. Um, interface range. Okay. No, not rep. No, no. On a R1, I'm going to create some loop back on R1. That's you know, it should be, come on. It should be 192.168.1.0/24, 2.0/24, and 3.0/24. Guys, I'm again repeating, I'm not teaching you the rip, I'm just telling you the problem. Okay. Loop back number 2, that's a 2.1. And loop back number 3, that's a 3.1. Then router rip. Let me convey this router rip. Come on. Version 2. We can enable with the version 1. We have a 2 version in the rip, right? Version 1 and version 2. Check the difference in the video, right? Because if I'm going to discuss of the version 2, it will take the 1 hour only on this thing, not over, even the 1 hour, 2 hours it will take, right? So that's why I prefer the video. Because I don't want to continue the RIP classes, because if I'm going to continue with the RIP classes, it will take the 1 week for the only level, not even the 1 week, 2 weeks only for the RIP classes, right? So it's totally waste of the time because nobody is using the RIP in the market. I'm just trying to show you the problem. So what happened? You can correlate, right, with the IGRP and then EIGRP. Why we came with the EIGRP protocol? Version 2, network, network, and network. On R2 as well as router RIP, version 2, network, 2.0. That's my physical interface, right? And also on R1, I need to enable this interface into the RIP. All done. Now have a look. Debug IP routing, debug IP RIP. Just wait for some time. I've advertised all this network into the RIP protocol. This interface has enabled in the RIP, and this interface has also enabled in the RIP. RIP works on the UDP, right? Port number 520. So can you see that I'm setting the version 2 update packet on the .9, okay, via 0/0 interface. So R2 is in the update packet to the .9. All this interface will join the multicast group. This is the multicast address for the RIP protocol, a class D range, right? Now have a look what R1 is doing over there. R1 is sending the one update packet to the R2, and in this update packet, what information they are putting? They are putting the 1.0/24 information, 2.0/24 information, and 3.0/24 information. And what R2 will do? R2 will add all this information in the routing table. Hey guys, please be on the time. If you're coming late, don't ask any questions. If you're not in the time, what happened? You will lose your things, right? And after that, you're going to ask me the question, no, I'm not able to understand this part. So please be on the time and don't take everything is easy. So now have a look what happened. R1 has sent the update packet to the R2. R2 will receive this update packet, and now we all have this entry in my routing table. Show IP root. See, not just show IP root rip. What I'm trying to show you right now, the R1 has sent a one update packet. If you capture this link, 12.1, and R1 is in this information, right? 12.1, R1 is in this information dot 520 UDP protocol number. .9 is a multicast address for the EGRP, and if you see the routing information protocol, we have these three information that R1 is sending, right? Just wait for the more 30 seconds. Again, have a look. 12.1 already was in the one routing information, that is the this guy, right? All this information after the, can you see that 30 second, right? Near around 30 second after that, what happened? Again, the router one is sending the same update. So now have a look. Two different update. Same router, same information is sending. What RIP protocol is doing actually over there, guys? What RIP is doing actually over there? RIP is doing the periodic update. RIP is doing at every 30 seconds. So it means that at every 30 second, right? At every 30 second, router one is going to share the complete routing information. Same information. Same information. It will continuously sending a complete routing. Can you have a look now over there in the R2 routing table? Receive the version 2 update, and after some time again same information I'm receiving from the 12.1 on 0/0 interface. R2 is receiving. R2 again receive same information. Again same information. If you have a look at the show IP route now, show IP route rep, what's the time is happening? 12 second, 16, right? For all this route, 20, 23, 25, 26, 27, 29, and now new update. 30 is happening. Once it come to the 0, what happened? New update. So every time router is going to be added, right? New update, 30-second over, remove the update, and again add new update. The first issue, it is doing the periodic update. This is the biggest problem of the RIP protocol. This is the biggest issue of the RIP. Because in this case, what happened? Your CPU will be high. Very, very high. And second thing is what? Wastage of bandwidth. Zero zero is directly connected next hop is. It's a directly connected next hop is in that 0.0.0. It's totally wastage of the bandwidth and the CPU will be high over there. What is the next issue is happening? See, what is the next issue is happening in the RIP protocol? Let's go to R1, and if you have a look over there, show IP, not R1, R2, show IP, you all, show IP interface brief. How many interfaces we have? Loopback number 1. I have a 28 interfaces, right? Can you see? All these interfaces are up and working fine. What I'm going to do over there, in RIP protocol, I'm going to advertise all this out. How we advertise all the single information? I'm just making a read issue. Don't worry about this command, guys. I'm just trying to show you the problem. Forget this command right now. I'm just advertising this route. How? I'm just using the one keyword redistribute. I'll let you know. We have a good discussion over this topic, right? Redistribute connected. And now have a look. Now, can you see the R2, right? R2 is sending how many update? 2 update. Open this guy. Awesome. And yep. And the second one, this one. Perfect. Now try to understand. R2 was a, right? Let me do one thing. Can I make it larger than? Now, yes. From the 2.0 to the 26, how many routes is happening? We have 25 routes. And then 2 routes over there, total 27 route. Same router. Can you see 12.2? And this is also a 12.2. This is also a 12.2 and this is also 12.2. It means that R2 has, R2 has, try to understand this part, R1 and R2. R2 has a information from 2.0 to 28.0. And what R2 is doing over there? R2 is sending the update packet. And in this update packet, what happens? In first update packet, they'll put the information from 2.0 to the 26.0. And now it will send another update packet. We have 27.0 and 28.0. See, they can, R2, right? R2 can put all this information, R2 can put all this information into the single update packet. R2 can put the all this information, whatever the information they have from this range, 2.0 to 28.0, they can put into single update. But how they are sending? 2 update packet, one update and another update. The reason is sending, right? The reason is sending the 2 update packet because RIP protocol, right? RIP update packet contains only up to 25 routes.
Okay.
They only contain up to 25 routes. So R2 will send the update packet. In this update packet, they will only have a 25 dot information, right? The header of the RIP protocol is defined like this. They can only put the 25 updates. The header of the RIP protocol is defined like this. They can only put the 25 updates. So it means that if you have a multiple updates, what is the wastage of bandwidth is happening over there? Take example. Just take example. If the router has a 1000 route, right? Now tell me, if the router has a 1000 routes, right? Now tell me how many update R2 will send. Of course, 40, right? Now 40 update packet R2 will send, right? At every 30 seconds. That is the update timer of RIP protocol. Now, if you have a look, what is the length of this packet? 546 byte, right? Depend on the depend on the how many dots they have. If you see the next one is 86, second one is first one is 546, and second one is 86 over there. And in the second one, the third one, that's R1 is 70, so 106. So depend on the packet, right? Depend on the vary, right? Now just assume that if one update packet, right, 40 update I'm sending over there, right? If one update packet is going to carry 500 bytes, how many update I'm sending? 40. Twenty thousand. 20,000 bytes, almost. You start right. 20,000 bytes. 160 kbps is happening. How? So 1,000 byte is 1,000 byte is 1 kbps, right? So 20,000 20 kbps, or the 160 kbps is happening. Bits per second. Yeah. Now, can you imagine? Do you know what happened? The time the RIP has introduced, right, in 90s. On the time, do you know what happened? We were using the serial link, and on the serial link, what is the maximum speed was happening with the 1.5 Mbps, and in the 1.5 Mbps, if I'm going to waste the 20 kbps at every 30 second, then and on the time we are not using the 1.5 Mbps link, right? We were using like a 500 kbps, 250 kbps, like this. I'm talking on the 90s. What is the first issue is happening with the RIP protocol, guys? It is doing the periodic update as second issue. They can only contain the 25 updates packet, 25 routes in the single update packet. What is the third issue? Third issue of the RIP protocol, RIP has a limited hop count. Hop count is a metric of RIP protocol. So maximum hop count is only 15. So if any route (16), it become a unreachable route. So can I deploy? Take example, we have router 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Can this user communicate with this person? No. Maximum is what? A hop count you can consider like a one router. It's a metric, right? It's a metric of the RIP protocol. AD value is a different thing. I'm coming to the AD value as well. As AD is comes in the picture whenever you have a different routing protocols. The route selection with the different routing protocols. Metric with the same routing protocol. RIF has the AD value as well as. So 20 is the AD and this is the hop count is the metric. 120 is the AD, this is the hop count is the metric. So can I deploy for the large network? Not applicable, right? It's not applicable for the large network. The fourth thing, it's not a scalable protocol. Scalable in the sense of what? Right now, whatever the technology data is coming, right? Maximum technology is not supported by the RIP protocol. It's not a scalable according to the our requirement right now in these days. According to the 90s, it was an awesome protocol, right? But now it's not awesome. It has lots of disadvantages. The fifth issue, right? It is a very slower protocol. A very slow. Yep. 30 seconds is happening in the update packet. Hold on is 180 second. Invalid is 180 second. And flush is 240 second. It means that I need to wait for the 240 second to flush this route in from the routing table. What is the next disadvantage of this person? If you have a R1, R2, R3, R4, and we have one server over there, and behind the server we have a host. Take example is the 4.0.0.0.0.0, and there is a one host behind the R1, and he wants to communicate, right? This guy wants to communicate with this person. If I'm going to implement the RIP protocol, try to understand this part is important. This is the 100 Mbps link, right? And this is the 1 gig link. Of course, Hari, it's a very, very big issue right now. Right now, we are dealing with the millisecond. In a 1 second, we have a 1000 millisecond, right? And we are dealing with the millisecond. And so 180 seconds is a very, very big time, very big time. If I'm going to implement the RIP protocol over there, guys, what is the RIP is happening? The RIP saying that, hey, I always find the best path. RIP saying that I always find the best path based on the like properties, metric. And what is the metric of the RIP? Hop count. Lower hop count is always preferred, right? What's the hop count is happening from this side? 2, and from this side 3. This guy always give the preference to the this path, not to the this path. Can you see that it's still 100 gig 1 gig link, right? It's a good one. It's a good one, right? But still it's going to prefer the other person. So are you able to deploy, right? Are you going to suggest anyone, hey, do one thing, deploy the RIP protocol in your network? And if you have a value of the link, like if you have a 10 gig and 1 gig, 20 gig and 100 MPS, no, because RIP only understands the hop count. This guy RIP protocol only understands the hop count. It doesn't matter what the bandwidth is there. Doesn't matter. I always give the preference to the lower hop count. Based on the requirement, we can manipulate the path. Okay, we'll say that, okay, you have to send the traffic from this link, not from this link. That is the different case. We can change this one, but we need to do some extra configuration, right? It's not a default, but we need to do some extra configuration. So these are my issues, right, guys? The first issue is what? The first issue of this protocol, it's doing the periodic update, right? Second issue, third issue, fourth one, fifth one, sixth one. To avoid this problem, what we have introduced? We have introduced the protocol that is name is IGRP. IGRP stands for Interior Gateway Routing Protocol. IGRP stands for Interior Gateway Routing Protocol. And what IGRP is saying that, hey, whatever the issue with the RIP protocol, whatever the issue is of the RIP protocol, the first of all, this guy has a limited hop count 15. I will resolve it. You can increase. What is the second issue with the RIP protocol? RIP saying that, hey, I only understand the RIP hop count, not the bandwidth. Okay, what happened? RIP IGRP is saying that, hey, I do have an ability to determine the properties of interface. And what are the properties of interface? We have a bandwidth, we have a delay, we have a reliability, we have a the load, and we have a MTU. So these are metric of IGRP. Both have a different features. Sorry, you have to follow the videos. RIP version was doing the broadcasting. Okay, it's a classful routing protocol, whereas the RIP version 2 is the classless. Is there any issue is happening? The biggest issue? It's fine, right? I can deploy for the large network. Introduced by Cisco. I think so 90s, 90, I'm not accurate the date, but before the 1993. So it was a Cisco proprietary protocol, right? What is the bad thing about the IGRP protocol? The bad why, right? It is a classful routing protocol. What is the meaning of classful routing protocol? This protocol update packet. A classful routing protocol does not contain the submit mask information in the update packet. Like how, if you have a look over there, I'll do one thing. Let's remove the RIP from this side, both the side. And I'm going to enable the RIP version 1. Just trying to show you the, the difference. Request. And you can see the RIP version 1 sending a packet to the broadcast address instead of the multicasting. That's a very, very biggest disadvantage of the RIP version 1, right? 1 minute. So its address is not a special matrix is 16, right? That's an invalid matrix. 1 minute. Let's go to the next one. Wait for the next update. Get up, man. Yeah. So now have a look. This one, copy, and I'll do one thing. I'll paste it over there, right? And I'll take another one, and that's we have this one. Perfect. That's version 2. So this is the classful, and this is the classless. Classful routing protocol does not contain the submit mask information. Can you see, is there any submit mask information? No, but I do have a submit mask information in the version 2. The version 2 is a classless, whereas version 1 is a classful. Cool. So IGRP routing protocol is a classful routing protocol, guys. The bad thing about the IGRP, it means that, take example, if R1 is there, right? And if R2 is there, and R1 has the information 1.1.1.0/24, and if R1 will send this information to the R2, how R1 will send this information in the classful routing protocol? 1.0.0.0. Am I sending the submit mask information? No. So what R2 will assume? Hey, this is the class A, and for the class A, what is the default submit mask information? /8. What is configured on this side? /24. What I'm getting over there? /8. It's bad thing. Incomplete information. If you have a class full, take example, if I'm sending, if I have something like this, 10.0.0.0/8, and I'm sending the 10. So R2 will understand, okay, this is the class A. And that's good because same thing is configured on this side and same thing I'm receiving on this side. But if you have a subnetted network, it's bad. What is the next disadvantage of the IGRP protocol? The next disadvantage of the IGRP protocol, the IGRP is a slow protocol. The update is happening 90 seconds. One more thing, one more about bad thing about the RIP protocol, I forget to explain over there. RIP, UDP. Whereas the good thing about the IGRP protocol, the IGRP works on the IP. Nine, it does not use UDP or neither TCP. It's have a own protocol number, guys. It's have a own protocol number. The protocol number is 9. What is the bad thing about the IGRP now? First is classful, second is slow, and third one, it always do the broadcasting. So it means that, take example, if we have a router 1, we have a switch over there, we have a router number 2, we have a router number 3, and we have a router number 4, and from this we have a switch 2, and from this we have a switch 3, and from this we have a 1000 host user, right? I'm going to enable the IGRP on this guy, on this guy, on this guy. R1 will send the update packet. In this update packet, what happened? The source MAC will be A. This is the interface MAC address. Destination MAC will be FFF, right? Source IP will be what? For example, this interface IP 101. Destination IP will be what? Broadcast. When this update is coming to the switch, what switch will do? By looking the MAC address, it will send the packet to this guy, this guy, this guy, this guy, this guy, and all the 1000 hosts. He's saying that, hey, I'm not interested to, I'm not running with the IGRP. Why should I entertain this packet? I'm not running with the IGRP. Why should I entertain this packet? Even not me. It's totally wastage of resources. Can you imagine what happened if you have a 10,000 plus host? They all keep receiving the IGRP update packet. Of course, after that they will drop it, right? They will drop it because they are not running with the IGRP, but still the bandwidth will be consumed, right? This link bandwidth, this link bandwidth, this link bandwidth, this link bandwidth. Well, yeah, I have unmuted. Yes, you can speak out now.
Sir, as you said, that too is the destination is the broadcasting.
Yeah.
So here it will flood to every router. So
Yeah.
suppose this is in the multicasting, okay, but still also it is multicasting, but still also it's behave like the broadcasting. So what is the difference?
How the multicasting be like a broadcasting?
So means suppose consider router one, router two, router three, all are in the same. Suppose take the ACE number, okay. So they are also in their.
They are, take example, they are running with the version 2, right? So they will join the multicast group dot 10, right? Dot 9. So only they will receive, no? Because they will join this multicast group.
Yes.
How the other person will receive it? Because are these two people are member of the dot 9 group? No. So they will not receive.
Sorry, router 4 and 3 are not in the same.
Yeah, not router 3 and router 4. Router 4 is not a member of the dot 9, right? So how does router 4 will receive this packet if I'm running with the multicasting?
Okay, okay, sir.
Guys,
Thank you.
these are my issues, right? Whatever the issues I have in the IGRP protocol. The IGRP issues is doing the broadcasting. It's a slow routing protocol, and it is a classful. To avoid this problem, we have introduced the concept of EIGRP. EIGRP means enhanced, the same IGRP. So I'm just enhancing the problem of IGRP, not enhancing, sorry. I'm just resolving the problem of IGRP. And the advanced version of the IGRP is known as a EIGRP protocol. The advanced version of IGRP is known as the EIGRP. So whatever the issues we do have in IGRP protocol, it was resolved by the EIGRP now. So EIGRP is saying that, hey, I'm a classless routing protocol. I can support everything. I'm a faster. 5 seconds, just 5 seconds is the whole hello time I have. And hold on time is 15 seconds. So as compared to the any routing protocol, I'm very faster. IGRP was doing the broadcasting. I do have ability to do the multicasting. So these are the main issues, right, of the IGRP issues I have resolved in the EIGRP protocol. And EIGRP has came in the 90s, if I'm not wrong. It's 1994. 1993 or near 3 and 4 is coming. Because itself in the 1993, they introduced the concept of classless. So whatever the classless protocol we have, whatever the classless protocol, all the classless protocol has came after the 1993, or we can say that in the 1993. Whatever the classless protocol, either we have a RIP version 2, EIGRP, OSPF version 2, BGP version 4, all these protocols support the classless. They came after the 1993, or we can say in 1993. And whatever the classful routing protocol, all those classful routing protocol came before the 1993, like a RIP version 1, IGRP protocol, BGP version 1, 2, 3. So IGRP was it's not IGRP, EIGRP introduced by the Cisco, but nowadays it's a IEEE standard. It's introduced by the Cisco, but in 2013, like they made an announcement, hey, it's now a IEEE standard, or maybe in the 2016 or 17, I think 17 or 16, they introduced the RFC of this guy. If you have a look, let me confirm the state. EAGRP. Okay, wiki. So if you see that EHRP replaced in the IGRP with the 1993, because in the 1993 we introduced the concept of classless, right? And now in 2013 it's make open standard, but in 2016 it introduced the RFC. So EHRP is just advanced distance vector routing protocol, and it's not doing the periodic update. I'll show you this thing. Don't worry about that. We almost have a, on only on the update packet we almost have 1 hour of lecture, 1+ hour of lecture, right? Don't worry about that. So it introduced by the Cisco system, but now it's a IEEE standard. So this is the reason, guys, why how this protocol is changing from static to the RIP, from static to the RIP to IGRP, and this is how the things will happen. RIP, then IGRP, and then EHGRP came in the picture. So hope you have a clear this thing, right? Why we are not preferring the RIP and IGRP protocol. So if somebody will ask you, hey, which protocol I need to deploy in my network, you have a clear picture of now. So RIP works on the UDP, IGRP works on the protocol number 9 or IP protocol, and this guy works on the protocol number 88, IP protocol. And it's a reliable protocol. Yep, RTP provides the reliability to the EHRP. We'll see that later on, not now, how the EHRP is a reliable protocol. The RTP was introduced by the Cisco, right? That's also layer 3 protocol, reliable transport protocol. Hey guys, anyone has a questions today in the difference between the classless and classful, right? RIP, IGRP, and why we are preferring the EHRP in the market nowadays? What's the reason? Anyone has questions? So guys, that's it for the done, because I can't start the EHRP. We'll see the tomorrow EHRP classes, right? I have to go network from today. So tomorrow we'll start the EHRP. RIP. But I'll just recommendation to all of you guys, please watch the RIP videos. Why 0.0.0? What is 0? Yes, that's a, it's a RIP protocol. It's going to return the next hop information. Yeah, thanks, sorry. That's only happening in the, the RIP protocol. In the update packet, you can see that already. But in the next routing table, it will next stop pointing to the router interface. Yeah, it was just guys, it was just a concise information, the concise information about the RIP and IGRP. But if you want to, detailed information about the RIP protocol, please watch the video. I'm telling you, you are not going to do lots of hard work on the RIP. You just need to watch the video and see what actually is RIP and how the RIP does work. Correct? Okay, guys, then see you tomorrow. Bye bye, and have a great day.
Thank you, Law.
Thanks, buddy.
Hello.
Yeah,
Sir,
hi, yes, tell me.
sir, I have one query. Actually, this is CCMP class, right?
Yeah,
And in the schedule chart, I saw the L3 routing, three
it's L,
routing.
yeah, it's L3 routing. Go on.
So in CCNP we are switching SD-WAN. So for those we have different batches, or
Yeah, first we need to finish with the routing, then switching, and then we have to go for the SD-WAN.
okay. So three lectures means
Three session.
three sessions, right?
Yeah,
Three sessions for CCNP. So routing, switching, and then SD-WAN.
right.
And automation also it is covering.
It's coming in the same part. SD-WAN automation, everything is coming in the same model.
Okay, so the L3 routing will take 1 month, then again switching will take 1 month.
Yeah, five weeks everything. 5 weeks this guy, 5 weeks this guy, and 6 to 7 weeks this guy.
Okay. Thank you, sir. Okay, thank you.
Okay, Law. Already next month batch schedule has been released, right? So when you gonna take our switching batch from what date?
This batch will finish. I will start the switching over there.
Okay, then it could be on month end, right?
Yep.
End of May,
Yep. 26 maybe.
26th May.
26 or 24 May maybe.
Okay. Sure. Thank you. Thank you.
Yep. I will save myself. Yeah, guys. Bye bye. And don't go outside. Please be safe, right?
Thank you, sir.
Thank you. Thank you, guys. Thank you. Thank you, everyone.